In this video, we're going to be talking about how to divide polynomials and monomials and using 0 as an exponent and talking about raising fractions to an exponent. So first, we want to look at what it means to have a variable to a power divided by the same variable to a power. Remember, the exponents are simply a way to shortcut how many times this variable is multiplied together. So there's 7 x's multiplied in the numerator in this case, 3 x's in the denominator, and if you'll notice, you can cancel each of those first 3 x's. We say cancel, but it really means x over x is 1, x over x is 1, x over x is 1, and 1 times anything is that thing. So you're just left with 4 x's. So basically, if you looked at the exponents, if you had just taken 7 and subtracted 3, 7 minus 3, you would get x to the 4th. So that leads us to this rule that says that if you have a base to an exponent in the numerator and a base to an exponent in the denominator, you can simply just subtract the exponents as long as b is not 0, because you can't divide by 0. So here, let's do a couple of example problems. And so there's 12 5s in the numerator being multiplied out and 4 5s in the denominator. So you can subtract the exponents, and so you're left with 8 5s multiplied together in the numerator. Down here, you have 9 x's being multiplied together in the numerator, 2 in the denominator. So you can simply just subtract the exponents, and you're left with 7. All right, again, this is 20 y's in the numerator being multiplied. There's 1 y that will end up canceling out with the 1 in the denominator. So you get y to the 19th power. Pretty straightforward. All right, so let's talk about using having anything raised to the 0 power. So no matter what it is, whether it's a number, a variable, a radical, it makes no difference. Anything that's raised to the 0 power is going to be equal to 1. All right, and that's essentially because if you had taken a base to the 4th power, for example, and then divided it by a base to the 4th power, and you use the rule that we just talked about, you would get b to the 0. And that would be the case. Anything raised to the 4th power divided by anything raised to the 4th power, they would all cancel and become 1. So the answer is 1. So anything to the 0 power is 1. Be careful that you are not supposed to include the part that isn't raised to the 0 power. Only the things that are raised to the 0 power will equal to 1. So if you have extra parts, they're not part of everything doesn't equal to 1. So you have to look at it. So the only thing in this case is a 7 raised to the 0 power. There's nothing else happening, so it's equal to 1. Everything here is being raised to the 0, so it's equal to 1. Now be careful here. This is not the same as -5 raised to the 0 power. These are two different problems. And this is because the negative is included in the raising of the power in this case, but the negative is out front in this case. This is essentially like saying -1 times 5 to the 0 power. That's what -5 here indicates. So since 5 to the 0 power is 1, and this is -1, when you take -1 and multiply it by 1, you get -1. That's why there's a different answer there. Again, in this case, x to the 0 is equal to 1, but the 10 is not to the 0 power, so you have to include that part. So 10 times 1 is just equal to 10. Now, if the 10 and the x were both raised to the 0 power, it's the same as saying 10 to the 0 times x to the 0, so it's 1 times 1, and you get 1. All right, so let's try a few. Try them, and then come back and check your answers on the video. All right, this one is 1. This whole thing is to the 0 power, so this is 1. This is the same thing as saying -1 times 10 to the 0 power. This is the same thing as saying 20 times 1, because the x to the 0 part is 1. And this whole thing is raised to the 0, so it would be equal to 1. All right, let's talk about if you had fractions and they're raised to a particular power. Fractions or quotients and fractions are similar. So there's a rule for exponents. If you have a fraction or a quotient and it's raised to a power or an exponent, those mean the same thing, both the numerator and the denominator are both raised to that same power. So if you have a fraction inside of here and they're both being raised to this exponent, you can separate them out as the numerator and the denominator. So let's look at a couple of examples. So x over 4 is both squared, which is the same thing as saying x over 4 times x over 4, right? Anything is squared is that thing times itself. So you end up getting x squared and 4 squared. And so when you simplify it, you get x squared over 16. Similarly, if you cube something, it's the same idea. Remember, whenever we raise a power to another power, it's actually going to be multiplied, not added, because you have 3 sets of these. So there's 3 2's, and so that makes 6. And then there's 3 sets of 5's multiplied in the denominator, and so that gives you the 125. Even if you have something more complex like this, 2 is raised to the 5th power, a cubed is raised to the 5th power, and b to the 4th is also raised to the 5th power. It's just in the denominator. So each piece of this is going to each be raised to the 5th power. So then you multiply it out, and then you simplify it. So 2 to the 5th power is the same as 5 2's multiplied together. A to the 3 times 5, you're multiplying it, because there's 5 sets of 3, so you multiply. And then there's 4 sets of 5, so you multiply. All right, try these two and then check your answers. Okay, so you should get x squared in the numerator and 5 squared in the denominator. You would simplify it to say x squared over 25. Here, 2 is being raised to the 4th power. A is being raised to the 10th power times 4, and B is being raised to the 3rd power times 4. So 2 to the 4th power is 16, and then you have A to the 40, and B to the 12th. Okay. All right, so let's talk about dividing monomials. Where a monomial, remember, you just have like one term, there's no adding or subtracting. I mean, you can have several variables in here, numbers, but basically you're not adding or subtracting anything. That's what makes it a monomial. So basically what you want to do is separate each term that's being added or subtracted by putting the denominator under each term. That's if you have a polynomial. And then divide the coefficients. Then you divide the variables using your exponent rules like you've been doing. So in this case, negative 12 divided by 4 is just going to be negative 3. And then the x to the 8th divided by x squared. Remember, you're going to have 8 x's multiplied and 2 in the denominator. So 2 of the x's will cancel out, so you can subtract, and you get this answer. Similarly, 15 divided by 3 is 5. 5 minus 2 is 3. And 4 minus 1 is 3. And that's how you get that one. Now, if you're adding, this is a polynomial divided by a monomial, you'll need to separate each part. So this denominator is going to go under each term. So you're going to have 10 x to the 8th divided by the denominator. And then you keep your addition because that's what was here. And then the second part divided by the denominator. So you do the same thing. You simplify. 10 over 5 is 2. X to the 8 minus 3 is x to the 5th. And x to the 6 minus 3 is x cubed. And 15 minus 5 is 3. All right, so try this. I kind of gave you a little bit of a hint here. All right, so 9 divided by 3 is 3. X to the 6 minus 1 is going to give you x to the 5th. Y to the 5 minus 2 is y cubed, because we're dividing. All right, looking at this one, you're going to have to separate each part. Negative 12x to the 8th plus 4x to the 6th. Okay. All right, so negative 12 divided by 4 is negative 3. 8 minus 2 is x to the 6th. 4 divided by 4 is 1. And then x to the 6 minus 2 is x to the 4th. And 8 minus 4 is negative 2 because it's a negative 8. And 3 minus 2 is 1, so we have the exponent of 1. Okay, last thing in this section that we want to talk about is how to divide polynomials that have multiple variables in them, 2 variables or more. So first you separate it into fractions just like we did a moment ago. Divide the coefficients, then use the exponent rules to simplify the variables. So in this case, we have this x's and y's and x's and y's. And remember, these top terms in the numerator cannot be combined because you have x to the 5th, y to the 4th. There's no other x to the 5th and y to the 4th. X cubed and y squared. This is not x cubed and y squared. Both the variable and their exponents must match exactly in order to combine the terms. But we can divide by unlike terms. That's okay. So I took this denominator and I put it under each piece of the numerator. That's what happened here. And then I went ahead and simplified. So 15 divided by 3 is 5. X to the 5th minus x squared is x cubed because 5 minus 2 is 3. Y to the 4th minus 1 is y cubed. There's a minus here, so we want to keep our minuses. 3 divided by 3 is 1. 3 minus 2 gives you a 1 as the exponent. Y squared divided by y is y. 9 divided by 3 is 3. And then the x squared and the y cancel. All right. Try this. Okay, let's look at it. 18x to the 7th y 6 over 6xy. And then 6x squared y cubed over 6xy. And 60xy over 6xy. So we want to simplify each term. 18 divided by 6 is 3. X to the 7th minus x to the first power, so 7 minus 1 is 6. Y to the 6th minus y to the 1st is y to the 5th. 6 divided by 6 is 1. X squared over x is x. Y cubed divided by y is y squared. And then 60 divided by 6 is 10. And the x's and the y's cancel. So you're left with 3x to the 6th, y to the 5th, minus xy, and plus 10. Okay, thank you very much.